Thanks for joining us for another edition of Tech Talks with Graphiant. Joining me today are two people that really need no introduction: Paul Ho, SE Director at Graphiant, and Barry Lee, Senior Sales Engineer at Graphiant. Today, we're going to talk through a very interesting topic called cloud networking, or as we're terming it, intercloud networking. We will go through kind of a quick landscape of where the solutions are today, what we see customers deploying, some of the challenges with those solutions, and then we'll look at what the solution that Graphiant offers, what we term an ideal solution, and then we'll walk through some of the customer use cases and see what customers are leveraging for this type of connectivity. So let's get right into it. Paul, you've been in networking and cloud networking for longer than the cloud has been a thing. What do you see for the current landscape around multi-cloud or intercloud networking? What do you see customers doing when you're out in the field?
Yeah, thanks, Matt. And thanks for alluding to me being really old.
You don't look a day over 29, Paul.
Thanks, Matt. I appreciate it. Yeah, so to the topic, right? I think cloud or multi-cloud networking is, I think customers are really doing multi-cloud networking, but why are they doing that? I think for many different reasons. You have very different applications in the different clouds, so that's one reason why customers are doing multi-cloud or have the need to connect different clouds together. For example, certain applications run better in AWS. Customers are using those apps. Customers could be putting their data lake in Azure for certain advantages. Oracle is pushing a lot of customers towards moving their on-prem Oracle databases into OCI, right? And GCP has,
not surprising that Oracle databases would work better in Oracle Cloud.
Yeah, that's that's very true. So you do see that. You have those kind of requests from customers to integrate their cloud environment with the Oracle's cloud environment. And then obviously GCP, a lot of great applications, or especially in AI applications run in GCP. And many examples, right? Azure AD, obviously runs in Azure. A lot of VDI. We see customers doing VDI applications in Azure as well. So, whether this is for one project or multiple projects that a customer has, or through mergers and acquisitions, your company is running one cloud and your acquisition or merger is running a different cloud. You are going to end up with a multi-cloud environment. So you do have the necessary, kind of requirements to integrate them, but not just connecting from on-prem to cloud, but also from cloud to cloud, right? And we consider the cloud environment as now the data center. We know a lot of customers who have pretty much ditched their data center, and they've moved, all of their workloads to the cloud. So definitely you want to treat those environments, workloads in the cloud and storage in the cloud, as data center, entities. So what we see, how customers are building today, and primarily, three technologies. One, they're using SD-WAN to connect the cloud. So you have SD-WAN routing that's already been established between data centers and then branches, right? So that's kind of a traditional WAN scenario. You have customers using traditional IPsec. So this is for kind of smaller environments where customers are doing lab testing, or they only have a few workloads. So they're using just traditional IPsec. It's a one-off, and then you have basically, you have to manage those keys and pre-shared keys and those IPsec environments. That's not integrated, right? So I think SD-WAN is a little more integrated. It's similar to traditional IPsec, but it's like one-off IPsec, connections to cloud's VPN gateways are less integrated. And then you have direct connect or direct to cloud, direct connection to cloud. It's typically through the data center. So these are, and that's, basically you need to, bring a circuit to your on-prem location, your data center location, and then, your enterprise will ride that connection into a colo facility where you have a cross connect to a cloud service provider, and then that's, you do that on a per region basis, wherever you're regionally deployed. So that's typically how things are done, and you have a mix. A lot of times you have a mix of these environments where it makes sense. So sorry.
I mean, we know a thing or two about SD-WAN and IPsec, but
yeah.
What challenges do you see with customers using those technologies to connect to their cloud?
Yeah, I think they're, aside, so a couple of things. I mean, one, if you want to treat the cloud like a data center, it's like you don't really connect your IPsec, your data centers with IPsec connections. You want to have a private connection, right? Obviously, with IPsec, you have performance and scalability limitations, and that's performance from a per tunnel basis, and then scalability from how many tunnels do you really need to have, and can you do any to any? So can any other site reach the cloud through tunnels, and how many sites do you have? So how many tunnels do you have to have? And then if you're going over the internet, right? So it's like, again, you're accessing your data center over the internet. So it's not ideal because you don't have SLAs on an internet-based solution. There's also operational overhead. You have to manage those IPsec tunnels configurations, especially if you're doing kind of a one-off IPsec tunnels. You have to troubleshoot those kind of tunnel bring up and things like that. You have to manage the additional workloads. If you're using SD-WAN, you're loading your VNF in the cloud providers. AWS, it's in a VPC, or in Azure, it's going into like a VNet in Azure, right? So you have to manage the routing. You have to manage the actual workloads that runs there. So there's extra cost.
Yeah, I was just going to say there's a cost penalty for that, right?
Yeah, so there's absolutely a cost penalty to those things. So in terms of cost, internet data egress charges are much higher than for like a private connection, for example. So if you make a comparison, say, like if the data comes out of Azure data lake, right, and you're kind of going into the data lake and it's coming out of the internet connection, if you're SD-WAN, whether that tunnel terminates to an AWS estate or it comes back onto on-prem, that data egresses Azure, you're paying in the US, you're paying 8.5 cents or 9 cents per gigabyte of that data. So it's much higher than like if you have a private connection, which is like 2 cents per gigabyte. So additional costs, you're like SD-WAN, license costs, you have those, and again, we talked about you have CPU charges, right? CPU, because you're running that instance or multiple instances, you have to have two for redundancy, and then you have to replicate that for additional tunnel support or additional regions that that you have. So I think a lot of the larger customers, we see customers standing up direct connections, and those obviously from a performance perspective are better. You can go much higher in terms of bandwidth. You are not going over the internet, right? So you don't have this kind of reliability issues. You do have SLAs with direct connection, and those can go into many gigabits, tens of gigabits, hundreds of gigabits, things like that. But I think one of the problems with a direct connection is it's not easy to do. It's not agile. It takes a long time it takes months to set up typically. So for anybody who's set this up before, you got to order your circuit from your data center to a colo facility where you want what a region that you want to be in. You need to have a presence in a colo, so you got to rent space for your routers to be there, and then you have to make a cross connect right to your cloud provider. from there. So the cross connect also takes time. You need kind of smart hands in the colo facility to actually do the cross connect. So all of these things take time, and once you set it up, it's pretty static. They don't really change. So it's you have contracts for circuits, and you have contracts for leasing space and things like that. So there's definitely a commitment that you make, and it's not something you can easily change. You require additional hardware. There's so obviously upfront costs to implementing that, and that connection is not encrypted. So that's going to be just a circuit. Your traffic is riding over a circuit, and you do a direct connect or an express route, fast connect. So for different cards, they have different sayings, the different names for these things. And then for doing that, and I think enterprise customers, many enterprise customers don't have the kind of expertise to do all of that very efficiently. So there's definitely also a knowledge gap, with the ability to kind of do this in multiple clouds, and integrating multiple clouds together. So
okay.
Yeah.
So, based on those challenges, so there's cost issues, there's flexibility issues, there is security, data sovereignty, encryption issues. Based on that, it seems like there's challenges with any of these solutions that you see customers doing. What do you see as kind of the needs, and what do you see as the ideal solution for what customers are trying to do with cloud connectivity?
Yeah, and thanks for the tee up, right? So, we think that the dream scenario for a customer, if I was the customer, and I've been on the customer side, and Barry has as well, and I think many of us that work at Graphiant have been on the customer side. The dream scenario would be just to have that as a service, have the performance, security, the encryption, and just be able to get me to any cloud, and integrate into any cloud in any region of the world that I want to be in, right, where my workloads are at, as a service, and delivered just in time. So say if I want to be connected to Azure in US East and AWS in US West, and GCP in another region, have that right away, right? So that would be nice as a service, if you can do that as a service, and have that all integrated, and have the high performance and a private transport and SLA that comes with that as a service. Have that as a path optimized, and in a low latency format, right? So you don't, what kind of latency and jitter you're getting across this path, because you have, you're going over a private network. Yeah, so it shouldn't matter where my app lives or where my database is living, or which region I need to be in. So that would be nice, right? So I think that's kind of like, I think that solves the multi-cloud, intercloud kind of equation that we've been talking about for like the last however number of years. And I think just make it easy, make it integrated with the routing that typical network engineers understand, and are able to troubleshoot just routing issues, and be able to control and have the visibility for everything. I think that would be great.
I think the flexibility and elasticity around flex up, flex down, or connect to different clouds as workloads move, that kind of thing is one of the things that I see coming from customers as well.
Absolutely. I think the flexibility is a huge thing. So not have contract tie-ins, right? It's like this month I have a lot of bandwidth going into a certain cloud, and maybe I don't need it anymore. After a couple of months, you can turn it down, right, and bring it up somewhere else. So those kind of things. I think those kind of things come with like as a service.
Absolutely. It's one of the key tenets of as a service, right?
Yep. Yeah, exactly.
Okay. So with all of that, Barry, I know you've done a lot of work with both testing and implementation with customers. I know you have built multiple platforms and done, like I said, multiple implementations with customers. Can you walk us through kind of what you've seen from an actual architecture perspective and what you've done testing on and some of the performances that you've seen?
Sure, yeah. So we recently helped quite a few customers building out their Intercloud environment, which they wanted to host their applications and data in different CSPs, right? And the performance is always their biggest concern. And we utilized our production testbed, did a very comprehensive set of baselining. Here are some results, right, that we documented. And after that, our customer feel much more comfortable, right, going multi-cloud by utilizing our solution. And look at the, this particular testbed that we built, right? Everything is connected to Graphiant stateless core over private links. We connected to 4 different CSPs, right? Azure, AWS, GCP, and Oracle OCI. And they connected to US East as well as US West, right? For baselining. We also have some sites that are connected to it, emulating as data centers. So one test that we did is a comparison between IPsec over internet versus Graphiant private connectivity. And as you can see, right, IPsec over internet, there is no SLA over the internet, and the latency is about 15% higher than our private connectivity. 75, 76 milliseconds versus our 67. And also you can take a look at the jitter itself, right? Over IPsec, over internet, the jitter is all over the place. And our jitter is consistently, under 0.5 milliseconds. And also,
and Barry, where is this location wise? Like where are you testing from and to?
Oh, it's a great question. Yeah, Paul. The test that we conducted is Azure East connected to AWS West, right? That's the where the test is conducted.
Thank you.
And the next test that we actually did is we compared AWS native backbone service, right? Utilizing a feature called a VPC peering, right? They also have something called a TGW peering, which is a very, very good solution compared to what we are offering in terms of latency and jitter. Based on the test number, our latency and jitter is comparable as AWS going through AWS's backbone, right? And also the cost, right, for inter-region peering is 2 cents per gigabyte for egress charge, and utilizing our solution is same, is 2 gigabytes per 2 cents per gigabyte, charging as well. And another thing that I want to mention is the jumbo frame support, right? We actually support jumbo frame over our backbone, connecting to different CSPs. For example, AWS to AWS, AWS to GCP, AWS to Oracle, AWS to data center, right? Any of those combination that we can actually support jumbo frame support. Versus some of the solutions right out there. I think we're the only one that can support jumbo frame for Intercloud today.
Yeah, I see your pings, right? You have the -M there.
Yes, -M do, right? That is just force the packet not to be fragmented, right? Yeah. So if I'm sending 8,000 bytes, a jumbo frame, right? That packet is not fragmented, right? It will get sent through, like over our network versus some other network or technology that, like if they don't support that, you will see some messages saying this, like a ping packet is too big.
Yeah, and you can only really support this over a private network, right? You can't do this over the SD-WAN.
Not SD-WAN, not internet, right? Nothing, right? Pretty much there's only private network like what we can offer today.
That's great.
And the next one that we documented is single cloud versus multi-cloud, right? So what we connected is AWS to AWS East-West, right? Versus AWS East connect to Azure West. As you can see from the performance perspective, right? They are very, very similar, right? So our, intercloud connectivity is kind of just like a single cloud, right? From the performance perspective. Not just from the latency, but also from the jitter perspective. As you can see, it's very, very consistent, always under 0.5 milliseconds for jitter. We also look at it, like AWS connect to GCP, right? So AWS East connect to GCP East. It is 2.0 millisecond.
Yeah, 1.9.
Actually, it's 1.9 right there because the first one is always slower because there is router lookup, right? So actually, it's under two milliseconds, and from AWS East to GCP West, right? GCP West actually is very interesting. They actually is not San Francisco. They actually is in LA, right? So as you can see, the latency is a little bit longer than the AWS East to AWS West, right? But still, it's a 68 milliseconds, right? It is a very, very impressive number that, if you, compared to other solutions that is currently, on the market.
Yeah, that's impressive. That's impressive. So you basically show the ability to go from, single cloud to multiple clouds, to cross cloud, right? Across the continent, jumble frames, right? In your testing, and these are available for customer demo as well, right?
Yep, it's ready for customer production, customer demo, right? We already built those infrastructure, right, to take on customer for production.
Yeah, and how's that integrated in the customer environment? How's the routing integrated?
The routing is very straightforward, right? It's a BGP routing that we support static route, BGP, OSPF, right? To the customer side, and we also for all the cloud connectivity, we integrate with the native constructs of each cloud. And so that makes, like the things, it's not proprietary, right? So that makes things much, much simpler. And it's a standard-based as well.
That's great.
Excellent. Thanks, Barry. That was a great overview and walk through of those use cases. So guys, I think the takeaways are multi-cloud networking doesn't have to be hard. When you deliver it as a service, it has the lower TCO, the agility, the flexibility, and the performance that customers need. And we really shouldn't see wide area networking or middle mile being a bottleneck in cloud connectivity anymore. Anything I missed?
No, I think that was great. I think the time to implement is really fast for Graphiant. If you want to have direct connection and you have to build it yourself, we talked about taking an extraordinarily long time to do, but with Graphiant, you can have it the same day.
So hours rather than weeks.
Hours rather than weeks. Exactly. Months.
Excellent. Cool. Well, thanks, guys. I appreciate the overview. Appreciate the feedback. If anybody listening is interested and would like to see more, reach out to us via our website, www.graphiant.com, and schedule a demo. Thanks.